So it's recording. Hi and welcome to this week's Brown Bag. Today we will have a presentation about microservices. And today's presenter is Jamie Coleman from IBM. So you can take it over and introduce yourself.
Thank you. I'm just going to share my screen. Bear with me. Okay, can you see my screen all right? That is the first question.
Yes.
Awesome. Let me just switch this around. Okay, so hello everybody. It's afternoon now, so I hope you're all enjoying lunch or munching down on something. My name's Jamie Coleman. I'm an engineer and developer advocate for IBM. I've had a bit of a weird career because I'm 28, but I've worked on mainframes. I worked on containers. I've worked on a DevOps pipeline. I've worked on Java application servers. So I've done quite a lot of things since I've been working at IBM. And now essentially I'm a software engineer. I'm mostly a developer advocate. So I talk about open technologies and open standards, stuff like that. And today I'm going to be showing you a presentation on how to create microservices with a completely open source kind of stack and some of the benefits that kind of brings you. Okay, so let's get started. So just an overview of what I'm going to talk about, a brief history of open source and kind of why it's important, a little bit about Eclipse MicroProfile and the stack and what that means, a bit about what OpenLiberty is, being a Java application server, a bit about OpenJ9, the JVM, and some of the things you can tweak with the JVM to actually make it a bit more powerful. And then finally, we're going to end on Openshift and kind of the importance of like a hybrid cloud, essentially. Okay, so this is a bit of information on the history of open source. It's a lot bigger than this, and there's a lot more information out there. This is kind of like some of the things that I compiled together. And I've kind of created a little timeline of some of the things I think are important for in terms of the history of open source. So the first real mention of open source is kind of here in 1953, where essentially a company ships their product to a client with the source code and essentially asks the client for feedback and comments on the actual code. And that's kind of really the first instance I can see of a company kind of employing or using open source to kind of get feedback on their code from, you know, the community. And then of course we go on a bit further. We've got the Linux kernel in 1991 and Debian Linux. They were very, very big milestones and very important things in terms of the history of open source. Of course, OpenJDK, open sourcing Java, another huge thing. But something for me and what I personally think has really changed the landscape is GitHub. GitHub has having a place where everyone can put their source code, everyone knows how to use it, people can comment, people can contribute, you can design workflows, you can even design with GitHub Actions the whole of your DevOps pipeline now using GitHub. Having this central one place that everyone to kind of, you know, communicate with each other has really changed, in my opinion, the landscape of open source. And I can't not talk about, in my opinion, the most successful open source product ever, Android. It's now the most used operating system. Sorry, I'm just going to move the chat over so I can see any questions. Can everyone hear me okay? I know one person's got a problem with sound.
I think it's a little bit of a Bluetooth. Do you have a Bluetooth?
I do have a Bluetooth headset, yeah.
So I think it's a little bit of a Bluetooth dropout hacker.
Okay, all right. I'll try not to move around as much. Hopefully that fixes it. But yeah, in my opinion, Android, obviously, it's the most used mobile operating system in the world. And that is an open source project. And I don't think without, you know, this whole timeline and all the things that have happened previously, I don't think Android would be where it is today without a lot of these other parts. So let's go to the next one. So a lot of the benefits are kind of, you probably know what they all are, but, you know, the main freedom, study, copy, modify, redistribute, that's kind of what you want with an open source project. Now, in regards to privacy and security, when you've got a open source project with a big community, all from different companies, all from different backgrounds, you are going to find bugs in your code a lot quicker. People will have different opinions, or they will have experienced things before. So the bigger the community you have with an open source project, the more bugs and the better the code generally will become, because you've got a lot more eyes looking at it. With open source software, you've got low to no cost. You start paying money when you want someone to shout at, essentially. If something goes wrong and you want a company to shout at, that's kind of where the optional licensing comes in. But all the technology I'm talking about today is completely free to use. which is great for like experimentation. So you can experiment to try out these products to see if they're good, see if they fit your needs, where you couldn't do that before when all this stuff was open source. Also, quality, collaboration, and efficiency. Again, you've got lots of people working throughout the globe. So, for example, in the UK, I could make a pull request, something might be broken, and by the time at the end of the day, and by the time I wake up, that could have been reviewed and merged. So, having a big community spread out across the globe makes your project a lot more agile, essentially. And of course, when you've got a project, say, and you've just got one organization that's creating this and building this in one company, they will have a very they will have their own vision for the project, and they will have what they think the clients want and what the clients need and what the customers need. Whereas if you have an open source project with lots of people contributing, it stops an organization or a company putting a project down a certain path and makes it a lot more agile and a lot more open. So yeah, just some of the benefits of kind of open source software, really. Okay, so just a bit about Eclipse MicroProfile, if you don't know what it is. Essentially, it's an open source specification for Java microservices. It was kind of created when kind of the cloud technology started taking off. Essentially, Java EE, which is now Jakarta EE, wasn't moving in the right direction quick enough. So a big community of individuals and organizations kind of came together to build what is now MicroProfile, to bring microservices to the enterprise Java community. And these are some of our contributors, and without some of these contributors, MicroProfile wouldn't be where it is today. Lots of different, there's loads of different contributors around the world. This is quite an old slide, so it's way more than 140 now. There's loads of different vendors, loads of Java user groups talk about MicroProfile now. So it's gone from a kind of a small open source project to now it's gaining a lot of traction and a lot of people are starting to use it, which is great. I'm not spying on anyone. This information is freely available, but I've just kind of tried to map out where some of our contributors are. And as you can see, it is really a global project. It does span a lot of different time zones. And I think that is really key for an open source project to kind of take off, is to have people all over the world, not only talking about it and using it and contributing to it, but again, making like it agile. So again, I could make a pull request here and someone on the West Coast could have accepted that, done a review and merged that by the time I wake up. So it really does help in a lot of ways, having a big community behind you. Lots of different ways to get involved. I'm not going to go through them all, but if you do want to get involved, there are these different ways. And if you want more information on that, please do let me know and I can put you in touch with the right people. So one of the great things about MicroProfile, and I always get asked this no matter how many times I talk about MicroProfile, why MicroProfile, why not Spring? And this is always the question I ask. So the first answer to that question is MicroProfile is vendor neutral. So I can go to lots of different vendors for support, whereas Spring, you're tied more to one vendor. The second thing, which this is something I personally noticed, and I haven't actually proved this with benchmarks and stuff, but generally starting up applications with MicroProfile seems to start up a lot quicker than Spring. Now I know Spring's a lot heavier and has a lot more stuff in it, but in a cloud native world where the difference between 1 second and 3 seconds of a startup is a massive thing when it comes to microservices. If you're just running a few microservices, that's just not that much of an issue. But when you're scaling to 100, those few seconds make a massive difference. And this is just something I've noticed. I haven't actually proved this, but in my experience, MicroProfile does run very quickly and starts up very quickly. So this is kind of the MicroProfile 3.3 stack. There is a 4.0 now, but the specs are pretty much the same. So the specs on the bottom are kind of the fundamentals for what we saw was kind of to create microservices. The second level is kind of to make your microservices more robust, so we don't have problems later down the line once they're deployed. And the third one is to kind of, is for observability, essentially. So once they are deployed, for us to go in and see if they're healthy, if they're not using too many resources, to make sure, requests are going to the right places, etc. So quick overview, it's quite simple. JAXRS, essentially all we have is a path endpoint, and that's the path we access the endpoint. And then we just app produces, consumes just the type of media we're producing there, and this is post request. So nice and simple. The RestClient essentially attaches to JAXRS endpoint, and the only difference here is the @register RestClient. Context dependency injection, or CDI, essentially allows you to inject applications, inject Java classes into your microservice. And it also allows you to manage the lifecycle. So for example, you could have request scopes. So when the request is finished, it will throw that Java object away. Or you can have application scope. So that object will stay there for the life, as long as the application is alive. And it's quite important with microservices because we don't want loads of stuff being left over every time someone makes a request. Microservices are supposed to be very small and agile. So managing the life cycle of some of the objects we use is paramount. JSONB and P. So JSONP is a parser, so it allows you to parse any incoming JSON. And JSONB is one of my favorite, and I use this all the time. Essentially, with very little setup whatsoever, you can turn a Java data object or a Java bean into JSON, and then that goes over the request. And then when it hits the other endpoint, the method will instantly turn that back into a Java bean, essentially, or a data object. So it makes sending data from microservice to microservice nice and easy, which is what I like. OpenAPI based on Swagger. So the problem is with microservices, now we've got all of these different teams, and you generally will have a team that will look after its own service. We can't just rely on those people talking to each other to figure out what these different endpoints do. So documenting them is paramount, and this is what OpenAPI provides. Now, it may be in our organization, we may sit next to that team so we can ask them what their endpoint does. But when we say externalize these endpoints, we need the users of our endpoints to know what they do. So this is where OpenAPI comes in. It also, with OpenLiberty, provides you with a website. And if you've used Swagger before, you know, you can try out the endpoint, put your own JSON in, see what kind of requests come back. So it's very, very useful. Of course, now we need to worry about security. We don't just have one big monolith. Now we have loads of services sending data over networks. So we need some kind of added level of security here. So JSON Web Token essentially just puts a token in the request header. And then essentially all you have to do is something simple like roles allowed, and then you can determine whether that request has the right access to essentially access that method. So that's kind of where JWT comes in. Fault tolerance is very cool, and this was kind of based off something, I think it's something that Netflix did quite a while ago. Now they don't use MicroProfile, they have their own technologies. I know they've moved away from this a little bit, but what this allows you to do, so for Netflix, I'm pretty sure every bar and every banner is another iframe on Netflix. And then they have microservices running those in the background. And for example, the recommendation banner, if that goes down, we don't want some horrible Java exception there or a 404 return. We want something to be displayed there. So what Netflix used to do is they would essentially have a backup microservice, which just had random kind of recommendations for the user. And when the microservice went down, it would then go and call the backup microservice. So from a user's point of view that's watching Netflix, yeah, I might think the recommendations are a bit dodgy and a bit weird, but from my point of view, it's still running, it's still working, it doesn't look like it's broken. I mean, I think that's kind of key in today's society. And what this allows you to do is, here I specified the timeout exception. I can do a certain amount of retries, etc. But there is also another element I can add here, which says go and call this other method if this fails. And essentially that method can then go and call off to a microservice it knows it works, or can try, you know, a backup microservice, or just display a nicer message than a 404 or a, you know, a Java core dump or something like that. And so that's kind of where fault tolerance comes in. Configuration, we don't want to configure each one of our microservices individually, so externalizing that is paramount. With MicroProfile, you can easily inject your configuration, and you can, with OpenLiberty, I don't know about with different runtimes, but with OpenLiberty, you can actually change your configuration and not have to restart the server, which is really good. And also having your configuration externalized, you can use that configuration for lots of microservices. So if I wanted to take down part of my application for maintenance, I can just change one config file and it would take down all of those microservices that, you know, have been scaled up, something like that. So it's quite useful, and it's really good for like DevOps and DevOps pipelines, because then you can specify different configurations as essentially your application or your microservice goes through your pipeline. Health, kind of what it says on the tin, you can define your own health endpoints. We need to make sure our microservices are healthy before we start bombarding them with requests. So that's kind of where health comes in. Metrics, so metrics, we get lots of information, for example, how much memory we're using, the heap size, lots of different things. But then, of course, we can do custom metrics. So as you can see here, I've got an counted annotation, which will essentially count the amount of coffee orders I make in my coffee shop application, which is quite useful. Open tracing, so now we need to trace all these requests going everywhere. And essentially, JAXRS methods are traced automatically, but we can do our own tracing just by adding the @trace annotation to a method. Okay, so where does this fit with Kubernetes and containers? Well, most microservices are all running in containers nowadays. So in terms of configuration, you can create Kubernetes config maps, which are injected into the application. As you can see here, here's the config map I've created, and then quite simply inject it like that. Also health, again, so Kubernetes plugs into the MicroProfile health endpoint. So whatever health endpoints we define, Kubernetes can then go and test them, because we don't want to be sending requests to our applications if they're not ready to receive requests. So it all kind of works well with Kubernetes. Test containers is something, I don't know how old it is, but I've been using this for about a year, and I absolutely love this technology. And essentially what it tries to do is, if you're using a production environment with containers for your organization or your project, this allows you to try as best as possible to replicate that locally on your machine. Now, as a tester, I don't want to have to install all these prereqs. I don't want to have to keep updating my database to make sure it's got the right, the right fields in and the right data in. So basically, what your production environment or what your DevOps engineers can do is they can produce these images or Docker files, entirely up to you, which as a developer, I can then use to try and replicate the production environment on my laptop. That way, containers are quite quick at coming up. I don't have loads of rubbish left over on my laptop afterwards. I can just throw it all away and start again. It's really good because there's loads of different implementations. The one I'm going to talk about is microshed testing. Loads of different runtimes. We've got OpenLiberty, we've got Pyara, Quarkus, Wildfly, so a lot of the main runtimes, which is cool. And again, it's very easy to turn a JUnit test into a microshed test. So simple annotation at the top, @microshed test. We define our container here. So here I've just defined the context route. We can put the port numbers in there. We can put a delay on there. So we essentially define a bit of our container in here. We import the RestClient because that's what we're going to test against. And then you would just test like you would any normal kind of JUnit test. So to turn a normal JUnit test into a microshed test, it's quite simple. I think you only need one dependency in your POM file, and then Maven already knows by you annotating that at the top that this is a microshed test, so it will run it as part of your testing stage, which is cool. So this is, again, Micro 3.3, a little bit old, but the specs are pretty much the same. And we have these standalone projects. So microshed testing is one of them. These are these are very interesting projects. Now, they are standalone. Whether or not they will come into MicroProfile later, we don't know. It's a conversation people are having. Again, it's an open source project, so we'll see where it goes. But they are, I think, if you're deploying microservices at a small level, having to worry about reactive architecture isn't so paramount. But when you start scaling it up, you have to start worrying about back pressure and, essentially queues of requests getting stuck. That's when reactive really comes into its own. Now, this isn't a reactive talk. I'm not going to give you an overview of how reactive architecture works, etc. But just it's something to keep in mind. Now, I'm not going to name a specific customer, but we had a customer, for example, that had a IT system, very big mobile phone kind of network provider. And they had problems when, for example, the new iPhone would come out and their system would go from a 1 second click response time on our website to 8 seconds. Now, 8 seconds is, it's way too much. So they rewrote everything. They put it all into reactive architecture. And not only did they get their 8 seconds down to less than 1 second, which was what their normal click rate is or response time, they managed to remove half of their infrastructure so they didn't need half of it. So like I said, reactive kind of architecture is very interesting, is very useful. You just need to know where to use it. And I think when you start scaling it up quite big, that's when it really comes into its own and helps. Right, so that's kind of the overview of where MicroProfile is. I'll just check the time. Okay, we're all good. So a very quick overview of what OpenLiberty is if you haven't heard of it. So this kind of spawned from, I presume you've all heard of Web Application Server. So basically, we have customers that have applications that have been running for 15 years on web application server. They haven't stopped it. They haven't restarted it. It just works. Now, don't get me wrong, it's a very powerful application server, but in terms for developers, it's not developer friendly. I mean, 10 minutes to start up is not a good thing. 8 gigabytes or whatever it is, 6 gigabytes minimal size is not a good thing for developers. So IBM kind of rewrote, we basically got a load of feedback, and we kind of created something called Web for Liberty, which we wanted to focus solely on developers, but we wanted it to have the power of Web for Application Server. So that's where Web for Liberty, and then about 3 years ago, IBM open sourced Web for Liberty along with our Java, which is called OpenJ9 now. I think that was the largest open source contribution we'd ever done. I can't remember how many millions of lines of code it was, but it was a lot, a crazy amount. So like I said, we wanted to focus on code. We want users to make fast and iterative changes, and I'll talk a little bit about that in regards to dev mode, which is something we've added. Again, true to production testing using stuff like microshed testing. We've got, so basically we were one of the first, so that's what one of the first things I did after working on the mainframe was, it was to kind of put Web for Liberty into a container, and we were the first IBM product, I think, to actually do that. So that's really cool, and we've been running in containers now for years and years. So they are production-ready containers, which is really cool. And in terms of tools, we don't want you to have to use tools. We want you to have to be able to do everything, everything you want without any tools. Now, we offer a lot of different tools, but we don't require them. They may make your life a bit easier, especially if you're using like lots of different parts of the stack. But generally, we wanted tools that are not in your way and not going to annoy you, essentially. Developer experience, so dev mode, essentially what this allows us to make code changes without restarting the application. So I think it takes about 0.1 seconds from the time I press Control S in my IDE for the time those code changes have taken effect. So by the time I've saved my file and clicked on my web browser, those changes would have already gone live. So it just makes developing code and applications just a lot easier with this kind of technology. And again, we've moved away from the traditional IBM docs, like Knowledge Center and stuff like that, and we've created a whole new website. So it's called OpenLiberty.io, and I just wanted to show you this page because essentially we've got loads of different guides on how to get started with a lot of different microprofile technologies, Kubernetes. And again, being an open source project, we try to stay unbiased. So we have stuff on here to do with AWS, Azure, lots of different things that aren't just IBM specific. So it's a really good place to go just to get started and try this stuff out. So I don't know who saw this, the 2020 Jakarta EE Developer Survey. They made a lot of bold statements in this survey, and as you can see, literally bold on this slide. And the one that I was looking at is the third one down. So the popularity of microservices may be waning with the usage of microservice architecture for implementing Java systems in the cloud declining since last year. So 39% to like 43%. Now, I don't know what your opinions are on this. I do not think that means microservices are going anywhere. And I still think microservices are where people should be aiming. If they're creating a net new project or a net new application, that is the kind of architecture I personally believe they should be trying to do. Now, breaking apart monoliths is a totally different story. So these, in my head, these are the different architecture styles. Now, of course, you've got your monolith, you've got your microservices, and you've got your functions as a service. But there's this weird little gray area, which I find a lot of people seem to find themselves in. Now, macroservices, I kind of find generally what I found is people that have tried to break apart a monolith, tried to go to here and gone, hang on a minute. I don't think that we can really decouple a lot of these things because they're so entwined, unless we rewrote the whole of our application. So macroservices I kind of define as right-sized services. Now, I've had people say, oh, isn't that a distributed monolith? No. A distributed monolith is a well-architected monolith. That's not a macroservice. What in my mind I would consider a macroservice, essentially. But yeah, so I find a lot of people try and break these apart. They realize getting to here, it's way too complex. And for example, so in a cloud, a monolith, don't get me wrong, they're great, but in a cloud environment, you know, if you have to scale one little part, I have to scale this whole thing, and that gets very, very costly. Now, if generally I can see these are quite highly coupled, it probably does make sense to scale just this part of the application because they probably would all three of them need scaling at the same time anyway. So I think macroservices are a really good place to be in, especially if you've got a monolith and you can break it down to this level, because it will save you a lot of money on the cloud, and it also saves, well, energy as well if we're not doing that. And it's not just me. A lot of people have kind of thought, that, microservices can be a bit too complicated, let's say, at times. But I still think, my personal opinion, if you create anything net new and it's going to be put on the cloud, function as a service on microservices is definitely the way to start that. But yeah, this is kind of where Liberty fits in, because it pretty much has all the functionality of Web3 application server, but we can start up in 1 second. Our memory footprint is absolutely tiny, so it makes it ideal for people that are using Web3 application server. Could stop using that and start using Web3 Liberty or OpenLiberty. But it also works well for macroservices and microservices. Now, function as a service is a bit different, because you need to start up services very quickly and shut them down very quickly, because they're essentially providing a function and then they shut down. But that's where OpenLiberty would struggle. But then there's technologies out there that can help that. So GraalVM and Quarkus, for example, they're perfect for function as a service, because they can start up very, very quickly. But for monoliths, macroservice, and microservice, a 1 second startup time with very small footprint, I think OpenLiberty fits really well into those different architectures. And this is kind of just to show you that combining different parts of a stack can help, especially when, for example, IBM has Influence in 2 parts of the stack. It means we can now optimize those things together, which we wouldn't be able to do, for example, if IBM didn't have Influence in different parts of the stack. So we've been chasing this 1 second startup time, which we've pretty much got to, and that's kind of come around for changes, but because of changes in the at time compiler and the introduction of shared class catch, which I will demonstrate in a moment. So this is just normal OpenLiberty starting up, basically with the normal hotspot JVM. And as you can see, it's pretty competitive compared to all the others. It's just over 2 seconds, but we want it lower than that. So OpenJ9 introduced something called shared class cache. What time is it? I won't have time to demo this for you today, but I'll see how close I get towards the end of the presentation. But essentially turning this on. So when I start OpenLiberty up in a container the first time, it'll just, with no changes, nothing, just normal Liberty, it'll start on for about 8 seconds. Now, just by enabling shared class cache, I can get that down to just over 1 second. And all I have to do is put one line in a file, and then that's it, it works. So as you can, shared class cache works with the other application servers as well. These have actually gone down from compared to hotspot. But again, having Influence in 2 parts of a stack allows us to innovate even more. So we managed to get this down to 1 second, which was pretty cool. Now, just some comparisons of Spring Boot. Now, Tomcat does start up a little bit faster than OpenLiberty. That's, hands down, it does that. But when we're talking about clouds, our footprint is, as you can see, massively smaller than Tomcat on Spring. And that means, what does that mean in the cloud? That I'm going to be paying 5 times much? But then, okay, maybe throughput's a little bit better. No, throughput on OpenLiberty is nearly double what Spring is on Tomcat. So imagine if we made this change for every application server running in the world and managed to make those savings. Imagine how much money and energy would be saved. Now, don't get me wrong, a load of cloud providers would probably lose a load of money. But yeah, just these small savings can make a big difference, especially when applied to the whole world. Okay, so that's kind of my overview of OpenLiberty. I'll talk a little bit about OpenJ9. So OpenJ9, this slide's a bit out of date, so I wouldn't pay too much attention to these, but I kind of kept it here because I wanted to, so I could talk about the different broad platform support. And I think now we even support ARM architecture, or at least we have a port to ARM, which is pretty cool. Now, OpenJ9, so the main differences for me is some of the different tweaks we can do. So for example, OpenJ9, if it's idle, it can save some memory. So it can reduce, so basically it can do this, which is good. Now, generally with a microservice, you want to shut it down if it's idle. That's the whole point. You want to scale it down. But for example, you might want to leave it up for a minute or 2 minutes or a certain amount of time, because you might all of a sudden get loads of requests again. So trying to save resources and energy in that time is paramount. And you always have to have one running anyway. So yeah, it's useful in a lot of circumstances. The JIT server I find also really cool. So essentially, it allows OpenJ9 to handle really constrained environments. So the orange line is just normal OpenJ9, and the blue one is it enabled with the JIT server. So 300 megabytes, no problems, pretty much perform the same. 256 meg. As you can see, OpenJ9, the normal application server, its throughput is going down. We can strain that to 200 meg, and all of a sudden it drops significantly. Whereas with with the JIT server enabled, it's still doing pretty well. So I don't know if anyone remembers, when I first started using containers, Java had an issue where it used to overleak. It used to leak into other containers and start seeing their resources. And this was really useful back then because it means even if it started doing that, at least the JVM would still be performing. So yeah, it's great if you've got like constrained resource environments, essentially. So the class cache sharing is what I was on about, and that's what we've been using to try and get down to that 1 second startup time. And it's really easy to enable on OpenLiberty. I presume with different Java application servers, they probably have different ways of enabling JVM arguments. But essentially how it works is normally a class loader would kind of go, it would be class loader cache, parent, and the file system. Whereas now we're using the class loader cache, parent, and now we're using the shared classes cache. So basically what I would do is I'd enable this. I'd start OpenLiberty up, and the first time it would start, it would take about 8 seconds, but then it'd be populating this cache here. So the second time, So the second time I go around and essentially run it, that will go down to, in a container I've been playing with this, down to about 1.8 seconds. Now, if you keep running that, it will basically essentially populate the cache and try and make it a bit faster. The lowest I've got it down into a container is about 1.6 seconds, essentially. So yeah, it's quite useful. And yeah, and that's basically all how you enable it. That's the argument. You just put the name. You can have different shared class caches as well, which is useful. So if you've got different projects running on the same machine, you can have different ones. The size is set to 32 megabytes on the next, but you can change that if you want to. Right, finally, just talk a little bit about OpenShift. So why should developers care about DevOps? You probably all know why developers should care about DevOps, but if you have a good DevOps pipeline, it really does help with innovation of your project. So I'll give you an example here. My partner, she used to work on a product that essentially they would write code in the morning, in the afternoon, and have it deployed to production that same day. Now, I've never heard about anyone doing that. That sounds crazy. But they were a very successful product. And, you know, that just shows how amazing their DevOps pipeline was just set up, that they could do that with confidence. And, you know, if I'm a developer, if I write some code in the day and I go home in the evening, you know, how nice it would be to see that that code is already deployed and the customer is using it. And so having a good DevOps pipeline is key. And that's one of the things OpenShift helps with, essentially. And of course, yeah, like I said, if you can get, you can do a lot more experimentation when you don't have to worry about all these bottlenecks and these problems going through DevOps pipelines and stuff. So what is OpenShift? It's a Kubernetes-based platform, basically, with a load of added functions. And it allows you to integrate with lots of different things. And I will talk about why I think OpenShift is important personally. But loads of different IDE integrations. So you've got obviously Eclipse, JBoss Developer, Visual Studio, etc. So you've got all the tools. So you can pretty much develop from your IDE and never have to leave it, which is, in my opinion, great, because then I don't have to bother about going to all these different systems and all these different places and managing user access, blah, 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 blah. So the main key thing is for OpenShift is the ability to deploy on lots of different clouds. Now, lots of clouds have Kubernetes, or most clouds have Kubernetes, but they all have their own little different ways of doing stuff, which is unique to their cloud, which then drives me absolutely crazy. But what kind of OpenShift allows you to do is deploy to any cloud. So as a developer, I deploy the same way I do on Azure, on AWS, on the IBM cloud, wherever I go, I can deploy in exactly the same way, because I know the underlying kind of Kubernetes manager is going to be the same no matter where I go. Now, why I ask, like, why does it matter about having multiple clouds? Well, data centers aren't, we have natural disasters. We have so many problems, and you can't guarantee that one cloud provider, can solve all those problems. They can try as hard as they can, but they can't, they can't know that a natural disaster is coming. So having spread around lots of different cloud providers and lots of different geolocations on a common platform just makes life a lot easier for developers and for your organizations. You don't have to worry about, stuff just breaking because some crazy earthquake has happened and stuff. So just to kind of wind down and finish up a little bit. So like I said, IBM does have influence over some of the stacks, and having, for example, OpenLiberty and OpenJ9, I work with some of the engineers. Well, they all work for Red Hat now, but I did work with some of the engineers that worked on OpenJ9. And working together, in an office near each other allows innovation, and it allows us to kind of really push different parts of the stack. Now, don't get me wrong, I'm not saying you have to use all of this stack, but if you can just try different parts of it. And for example, OpenJ9, if you're using container architecture, it's really easy to swap out the underlying image to try OpenJ9. And even the class cache sharing, even stuff like starting up Eclipse, that has massively reduced in time by me just playing around with the JVM. So yeah, do test out some of the different parts of this stack, and hopefully some of it will be useful to you. And yeah, this was just kind of a chart to kind of just show basically the performance and the hardware and software improvements that have enabled us. So for example, IBM with WebSphere, and obviously they have history on ZOS, have been able to influence both parts of the stack has now enabled us to basically constantly improve the performance going forward. So yeah, that's pretty much the rest of my presentation. I won't do a demo because we've only got 15 minutes left. But essentially, just a quick recap, MicroProfile, you don't have no vendor lock-in. In my experience, starts up very, very quickly, which is really key, I find, for cloud-native development. And the community is big, and it's getting bigger, which is really good. OpenLiberty, again, it's a modular application server. So you can get it for like 40 megabytes, but then you just add the features you want going forward. So very different to the traditional way WebSphere used to do things. Again, really lightweight. It's very easy to configure. There's just one XML file to go in and do. Jakarta EE8 certified. I think we were the first application server to be Jakarta EE8 certified, and we actually have, I think, Jakarta EE9 support in our beta as well, which is really cool. It's production ready, and again, we've got official Docker images available, so it's really easy to get started with. OpenJ9, again, low memory footprint, fast startup time. The throughput is really, really good, and it's got really smooth ramp up time on the cloud. So I didn't mention that before when I was talking about OpenJ9, but the time it takes your JVM to start and ramp up, that is just completely wasted money, completely wasted electricity. Like there's no point in it. So if we can ramp up and get to where we should be very quickly, we can remove that waste. And the main thing for OpenShift is, again, it allows developers to deploy in the same way, no matter what cloud they're deploying to, but having the main thing, not so much to do with OpenShift, but the main thing to take away of that is deploy to as many different providers as possible, even if it's just small, like a small amount of services on each one, because if anything ever happens, a natural disaster or this or that happens, yes, it may be the least of your problems, but at least your application, everything will still run. And OpenShift is very good at that. So if you've ever seen a talk by Burstutter, he does some great talks where he shows you just shutting down AWS, and all of a sudden all the workloads get ported to a totally different Azure and stuff like that. So and it's all open source. So 20 years ago, would you be able to build like enterprise software same you can now with all open source software? No, you wouldn't. So it's great. We live in a time where all these open source projects have done so well, and it just allows us to play with all these cool technologies. Yeah, that's pretty much the end of my talk. If you want to reach out to me after this, after we've had our conversation, our talk afterwards, my email's there and my Twitter's there as well. So yeah, thank you. Is that all right?
Perfect. Thank you.
No worries. Right, question.
No demo today, so I'm ending the recording. Then